Math 6, Module 3, Lesson 16, Symmetry in the Coordinate Plane. How are the ordered pairs 4, 9 and 4, -9 similar? How are they different? Are the 2 points related by a reflection over an axis in the coordinate plane? If so, indicate which axis is the line of symmetry between the two, or between the points. If they are not related by a reflection over an axis in the coordinate plane, explain how you know. So the first thing we're going to do is draw it. First thing we're going to do is draw it. Oh. Well, I'm going to draw 1, 2, 3, 4, 5, 6, 7. That should be enough because all I need is 4, right? And then I need 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that's all I need, right? Now, for the sake of doing this, I'm going to show you how I label my axis. Or not my axis, but my points here. So, I only write the numbers in the first and the third quadrant. Why would I do that? But I'm writing in the first and the third quadrant. What are all the points in the first quadrant? Positive. What are all the points in the third quadrant? Negative. So this is how I do that. I say 1. This is a little bit harder to do on here. And then I would say 2, 3, 4, 5, 6, 7, 8, 9, and 10. 2, 3, 4, 5, 6, and 7. And then I come over here and I say -1, -2, -3, -4, -5, -6, -7, -8, -9, -10, -2, -3, -4, -5, -6, -7, -8. Is this how you have to do it? No, but you do have to label them. Okay? You can move the numbers on the, you can move these numbers right here to the bottom down here, right? You could move these on this side of the line if you wanted to. But I just showed you the way that Mr. Anderson does it. Okay? Let's add back my little tally here. Now, this says 4 and 9. So we're going to go over 4, up 9. So if we do that, let me try and make this a different color here. Okay. Over 4, up 9 would be right here. Now if I go to 4, -9, I'm still going to the right 4, but now I'm going down 9. So it's going to be right here. Okay. Now remember, you need to say 4, 9, 4, -9. So here's a neat story about Mr. Anderson. My math teacher in high school still likes to remind me of this. You know, we can do one problem on this graph, right? And it not get too much information on there. Well, Mr. Anderson, remember, was not a good student. Okay? Not a good student. I did my entire homework on one graph. So if it was 30 questions, I did every one of those on the same exact graph. I just made one big graph. Number 1, plot it. Number 2, plot it. Number 3, and I did that 30 times or however many problems they were. And she about died whenever she looked at my paper. She was like, are you kidding me? Like, no. So you need to do a different graph for every problem. Okay? Now, let's talk about these though. How are they similar and how are they different? Well, we're going to say the x's are both 4, right? But they're different because the y's are equal to 9 and the y's equal to a negative 9. Right? So the 9 or the y's are what? Opposites. They're opposites. Now, let's think about this. If the x's were opposite, if we had a positive 4 and a negative 4, okay, those are opposites. Are those symmetrical? Do y'all know what symmetrical is? Okay, so there's the same distance away from 0, right? There's 4 to the right and 4 to the left. Now, if we're looking at the y, we're not looking at our horizontal axis or our horizontal number line. Now we're looking at the vertical number line. Is it symmetrical? Are those 2 points symmetrical? Are the y's opposites? Yes. So that means since the x's are the same and the y's are opposites, that means it is reflected across what axis? It's reflected over the x-axis. They're on the y. That's what we're looking at as the y number line. So they would have to reflect over the x. Okay? So we would say, yes, symmetrical about the x-axis. Now, when I say about, I'm not saying close to the x-axis. That's not what about means there. Have you ever seen in military a movie scene where the military say about face? They don't come up to you and go, they don't get about to your face, do they? No, they have turn around. An about face is to turn around. So we're saying it's yes, and it's about the x-axis. It's flipped over the x-axis. Okay? Now, number 2 says, given the point, all right, we got a new point, new problem. Whoop. So we are going to draw a new graph, right? If it asks us to. Let's see what it says. Given the point -5, 2, write the coordinates of each or of a point that is reflected. I'm sorry. Let me start all over with this. Let me try and read this correctly. Given the point -5, 2, write the coordinates of a point that is related by a reflection over the x or y axis. Specify which axis is the line of symmetry. Now, so we don't have to draw an axis or draw a graph here. We're looking at -5, 2. So, this is what you need to do to answer this problem. Okay? Listen, this is how you answer it. You say, I'm going to reflect it over the x-axis. Remember, it told you to tell me which axis you're going to write it over. So I'm going to say, I'm going to reflect it over the x-axis. Okay? Therefore, what would the points be? Well, if I'm reflecting it over the x-axis, what has to change? Does your x change or your y change? Your y changes. Okay? So we're going to say -5 and a -2 because we're going to do the opposite of our y. Now, if I said the y-axis, what would our point be? What's got to change if we're reflecting over the y-axis? The x is going to change. So we're going to do the opposite of a -5. That's a +5. What do we do with the y? Just keep it. Okay? So listen, if you're having to give the symmetry of a point over a certain axis, okay, you change the opposite coordinate. Okay? So if it's the x-axis, you're going to change the y-coordinate. If it's reflecting over the y-axis, you're going to change the x-axis. Okay? That's simple. All right, let's go to page, or go to lesson 17 now. I think there was just one page. Yep. Okay, so page 1 for lesson 17. It says, draw the coordinate plane and points on the plane. Determine an appropriate scale for the set of points given below. Draw and label the coordinate plane, and then locate and label the set of points. Okay, so this is talking about our scale. So how much each box counts, what each increment is. Now we know we have a y-axis and an x-axis, right? So let's draw those. Let's do it right here. Okay? And let's do it. Let's see if I can let's do that better. I think there's a way for me to draw a straight line. Let's see if I can do that. A line. Here we go. Draw it right here. Can y'all see that blue on there? Okay. That pretty straight lines I got there. Okay? Now, it says we've got our x and our y, but it wants us to determine the appropriate scale. So if I look at my x's up here, I have 10, negative 25, 0, 20, and negative 5. What are we going to use for each increment? All right, let's do 5. So I have 0 here, right? I normally put 0 in one of the little corners. And then I say 5, 10, 15, 20, 25. And so down here would be negative 5, negative 10, negative 15, negative 20, negative 25. Okay, that has our y's. Oh, why'd y'all let me do that? That's wrong. That was our x. Mr. Anderson messed up. What? 5, 10, 15, 20, 25, negative 5, negative 10, negative 15, negative 20, negative 25. Now, and if you wanted to, like, see how mine's kind of pushed together there? If you wanted to do something like negative 5, negative 10, negative 15, negative 20, negative 25, to make it look a little bit better, easier to read, that's fine too. Now, does that mean we need to use 5s for our y? No. So let's look at it. What does it need to be? 1. Whoops, sorry. So you're going to go by ones each time? If the 0.2? Okay, what is 0.2 as a fraction? Anybody know? 2 over 10 or 1/5. Remember, whenever you see 0.2, 0.4, 0.6, 0.8, think of fifths. Okay? So let's do 0.2. That'll work. So now we're going to have, here, we're going to have to do it differently because we don't have the same increment here. So on this side, I'm going to say 0.2, 0.4, 0.6, 0.8, and 1. Down through here, I'm going to say negative 0.2, negative 0.4, negative 0.6, negative 0.8, and negative 1. Now, did it say draw and label coordinate plane, and then locate the label and label each point? Okay, so I'm going to change color here, and we will do these. Let's do a light blue here, see if we can do that. Okay, now it says 10 point and 10 for the x, and then 0.2. So that's going to be right here. And we can say that is 10, 0.2. Now we have negative 25.8. So over to the left, negative 25, down to 0.8. So negative 25 and 0.8. Oh, wait. I didn't do that right. Got to check it again. That's going to be up to 0.8. So that's negative 25 and 0.8. Okay. 0, negative 0.4. What quadrant is that in? 0, negative 0.4 is in the second quadrant. What is this quadrant? Quadrant. Yeah. What quadrant is that in? That's it. It's not in a quadrant. It lies on the y-axis. Lies on the y-axis. All right, so go to 20, up 1. So this one is 20 and 1. And then we have negative 5 and negative 0.8. Negative 5, negative 0.8. All right. And that is all you had to do.